Yeah, I'll just give a quick intro for Nolan. So Nolan Grace is a senior solutions architect at Lightbend, um, and he's been working with the Cloudflow product for a little while now. Cloudflow has been around it's been open source for not too long now, but it's a new project by Lightbend to make it easy to run various open source stream runners in a Kubernetes environment. I'll let Nolan introduce it more thoroughly. So welcome, Nolan. Thanks for doing this presentation for us.
No problem. Thanks for having me. I'm happy to, and I'm really excited to talk about Cloudflow because, as you know, Sean, it's something that we've been kind of working on for a while at Lightbend. First kind of internally, and then we open sourced it, in the last 3 to 6 months. But I'd like to, I'm really looking to get more feedback on the product, and just see, what's nice, what's not nice, what people like, what they don't like, and really get more kind of just feedback from people. And I think that's, kind of a great introduction to me. So my name is Nolan Grace. I actually live in Chicago. So that's where I am right now. So pretty much the same weather as Toronto. Not great yet this year. I'm looking forward to the summer. But really, I've been working at Lightbend for a couple years now, and my job is I basically go around talking to customers about what's their current architecture, where are they trying to go, what kind of things they're working on, working on POCs, things like that, and then really trying to understand what's missing in the space, what's really going to help development teams accelerate, where are their biggest challenges, things along those lines. And so, shameless plug for Lightbend. For those of you who don't know Lightbend, we're highly involved in the Scala community. So Martin Odersky, the creator of Scala, is one of our co-founders, and then Jonas Bonaire, the creator of Akka, is our other co-founder. And we have a lot of open source tools, and kind of these 3 boxes at the top. But specifically today, I'm going to be talking about a Cloudflow tool that's been open sourced recently. So what is Cloudflow? Where did it come from? What does it do? All things we will be talking about today. But really, it came from a big challenge that we were having at Lightbend. So for those of you who know Lightbend, we had a product called the Fast Data Platform. Fast Data Platform was really focused around streaming use cases. And it was really around bringing more of these great tools in the industry together to build really high quality applications. So bringing Kafka, Spark, Akka streams, all of these tools together in kind of one application ecosystem. And there were a lot of challenges associated with building apps in that way. As you can kind of tell from this diagram here, there's a bit of a hairball of microservices and Kafka topics, and dealing with schemas associated with messaging schemas, and then sometimes Spark ran on Mesos, and then Kafka runs on straight up or AWS nodes, and then Akka might run in Kubernetes, or it might run in Mesos, and it was just like a huge hairball of stuff, interdependencies, all these different pieces. And then on top of that, most of the time spent building these applications was really focused on plumbing and infrastructure, as opposed to really building out business logic. Focus more on connecting Akka with Kafka with the right schemas, and making sure that Kafka was running right and Akka was running right, and worrying about Kubernetes YAML and all these things, and not focused on really the business logic and the features that really was the point of these applications. Also learning from the present. From talking to customers that are really focused in building real-time streaming applications, there's a worrying trend for me right now, and that is basically monolithic streaming applications. Lots of organizations kind of settle on one technology that decide we're going to use Spark for streaming, or we're going to use Flink for streaming, and then that's the only tool they use for streaming. They really kind of put their blinders on and say, if it's streaming, it's Flink. And not only that, they build these huge, massive applications. And there's a lot of reasons for that. You know, a lot of it is kind of some of the stuff that we try to approach with Cloudflow. But you know, you really end up with, you know, brittle, massive applications. And so, you know, hopefully the idea is that Cloudflow is a tool that can make it easier to kind of break up these streaming monoliths into, you know, these different pieces. But so is everybody with me so far? I mean, if there are any questions, I'm perfect. So I'm looking at the chat too. So I pulled up the meetup on my phone so I can see if people post in the chat. I can see that and I'll comment, or feel free to unmute yourself and just say something. There's a lot of people, so it could become chaotic, but if you have questions, please ask. With that, I will keep moving forward. So I like to do this in a lot of my decks is I come up with this huge list of stuff that, you know, a new service, a new practice, a new framework does, and then slowly I consolidate that into, you know, a smaller and smaller list. And you know, really the challenges that we were experiencing with the initial kind of setup of the fast data platform, and then microservices, or I'm sorry, with streaming architecture right now, you know, it would be better with less boilerplate code. It'd be better if you could really use the right tool for the job. And I feel like that's something, you know, that's appropriate in all software is, you know, there's a lot of frameworks, there's a lot of tools and best practices out there. Let's, you know, use the right one for specific use cases and not spend all of our time as software developers trying to fit square pegs into round holes. And then less plumbing. I think everybody would be happy to spend less time, you know, hooking things together, more time writing functions and writing, you know, operations and features, less time hooking things together or making sure things get deployed. So writing less Kubernetes YAML, worrying less about deploying something to Mesos or Spark cluster, things like that. And then, you know, I'm a big fan of, you know, microservices best practices. There's I think a diminishing curve on that, but you know, making sure that we can have isolation services, making sure that we can deploy things, you know, more quickly. And so using the good pieces of microservices best practices, you know, in our streaming architecture. Questions on this? Any big disagreements here? Do people on the chat have you know, experience building kind of big monolithic streaming applications, or you know, does this resonate so far?
Yep.
Good. Okay, cool. Let's talk something interesting then. As opposed to problems, let's talk more solutions. So Lightbend has released this open source product. It's called, or this open source project called Cloudflow. And really, Cloudflow is made up of two main pieces. First, it's an API that you know, kind of defines the bounds of you know, what we call streamlets. And so it's about, you know, creating these streamlets, these micro stream services, and stitching them together and making it easy for them to work together. You know, Java and Scala APIs, and then the other side of it is a Kubernetes operator. So really making it easy to you know, test locally, build, and then deploy onto Kubernetes without spending your whole life writing Kubernetes YAML. So the first part, the API. So the Streamlet abstraction in Cloudflow really is just a box, and this box is a stream. And so, you know, to start making this actually useful, so the Streamlet currently has 3 different engines. So you can build 3 different types of streaming streamlets. So Apache Spark structured streaming, Akka streams, or Flink. So what you do is you take this box, you extend it, and then you write the streaming business logic that you want in you know, Spark structured streaming, in Akka or Flink. So first, you know, that's pretty straightforward. Everyone can build a streaming application, but you know, the next level is, you know, how do we get it to work with other things? So now all of a sudden we need to start defining connectors. How does it have a relationship with other streaming applications? And so that's where, you know, along with defining your business logic, you also define the inlets and the outlets of your stream. So, you know, you can have between zero and I don't know what the upward bound is, but infinity inlets and zero and infinity outlets. And now all of a sudden you can start. You have this little streaming operation that can now collaborate with other little streaming applications, but we have to define how we stitch these things together. How do we define this streamlet then feeds into this streamlet, then feeds into this streamlet. And that's where we have this concept of a blueprint. So far what we've done is you extend this streamlet object, this streamlet abstract class. You write your Akka business logic, you write your Spark business logic, you define inlets, you define outlets, and then you hook things together. You define, this Spark streamlet here has a outlet of this type that goes into the inlet of this Akka streams application. And so now we can start breaking down, building smaller streaming applications that have more isolated, use cases, more isolated responsibilities. And we can start using for, okay, so Spark is great with this thing. We want to start reading from this data source. We really like how Spark reads from this specific data source. We want to window and aggregate, but then we want to do something that's embarrassingly parallel and something that's really appropriate for Akka streams. And so, we can just define the logic in Akka streams, and then same thing with Flink. We can start using all these streaming engines in one kind of application, in one use case all together. And we can have strong typing from end to end. And, we can actually, build it in one project, test it in one project. Sorry. So questions on that so far? And I know this is still extremely abstract. Once we go into the code, I think it'll make a lot more sense. Don't worry, there is a whole demo. We can look at code and really get into the weeds. So questions on that so far?
Yes, question, Nolan.
Yep.
In the box in the middle, where there is two inlet, what if the two inlet, they are time related? That means, for example, I want to the Spark had to use some data that should exist in the other green inlet, and then somehow their timing are not synchronized. So
which they absolutely will always never be synchronized. That's just a aspect of building a distributed system or anything in microservices. But each of the messages moving through is going to have some sort of timestamp, and that really comes back to this story of using the right streaming engine for a specific job. Akka streams, or even if you can jump into the higher level of Akka clustering and sharding, is really it's not well suited to be doing windowing and aggregating on timestamp, but Flink and Spark are extremely appropriate for those use cases. And so I could easily have swapped these two and have Spark in the middle, which I actually, well, I'll show you a Spark example later where I do windowing and aggregation. And so the ability to basically in Spark structured streaming have two structured streaming data sets and joining those on a specific window. So I'm waiting for potentially late data from either inlet. Absolutely doable in Cloudflow.
Okay, cool.
So yes.
Quickly, sorry. So as I understand, the blueprint is for connecting these streamlets together, and it is transforming these like streamlets collectively into an application, as we are saying. But when we are building this blueprint, is this something that we have to do declaratively, or is there a visual tool for that?
Important thing about Cloudflow is it's all, development is all in your IDE. So we don't currently have like a drag and drop UI for things. That's something that's always possible in the future. It's an open source tool, but I think it kind of, in a minute we'll go in, we'll actually look at a blueprint and what it looks like. And if you wanted to create a drag and drop, it would be pretty easy. It's just a configuration file, but really I think that the meat and potatoes and kind of surprisingly is this piece here. It seems so simple, but once you can start using it together with all these things, it makes things a lot more interesting. And then I'll also mention each of these lines is it's a Kafka topic on the back end. So Cloudflow will actually make sure, so we're basically using Kafka topics as a communication protocol between these streamlets. So, when things get deployed into Kubernetes, each streamlet is actually a isolated Kubernetes deployment. So everything gets put into one Kubernetes namespace. Each streamlet becomes, its own independently monitorable and scalable Kubernetes deployment. And then the communication between those deployments is done via Kafka topic. And Cloudflow will actually make sure that those Kafka topics are spun up and available on deploy. So we have a couple different ways of doing that, but we'll dive more into it later. But really, we get back to this whole message of, spending less time worrying about the plumbing. So relying on a Kubernetes operator and a blueprint to kind of define more of this plumbing for you, so you can spend more time writing the business logic that goes inside the box. And then another big thing that it can be a little hard to kind of grasp because there's not a line on the diagram. How do we, so in these, these starting, ingress points, how do we pull data in? And any of these boxes is just a normal, straightforward Flink application. It's a normal Akka application. We give it kind of, a stream that it can subscribe to, but it actually gets to define, how it consumes these things and how it converts, messages from here into messages that go out here. And so same thing with any of these, I could expose a REST endpoint on here just using normal Akka HTTP code if I wanted to. And same thing, Spark right here, I could, just with normal Spark code, go read from HDFS or HBase or, some sort of external Kafka topic if that's what I wanted to do. And then same with Akka, you could use all of the Alpaca connectors to connect to some, externally managed source. You could create a gRPC REST point. So we have messages coming in via gRPC, or we could subscribe to a JDBC database and be, constantly scrolling through things. However you need to get the data into this streaming application, we can. So let's look at some code now. I have a picture of a car because cars are cool and I like cars, and this is a cool car. The use case that I have set up for this demo is actually a connected cars use case. The idea that, we have information, telemetry that's being fed from, smart cars. Let's say it's a Tesla or a Ford GT, information about speed, how many miles it's going, things like that. All of this data is being fed into our application, and we need to process, bend and twist this data in order to make it useful to kind of different teams. And so that's what's happening in our use case here. So I will mention this UI is actually the commercial UI for monitoring Cloudflow. But it's just a really nice way to kind of, show, this is an application running in Kubernetes. So you could do all the same thing with the open source, but the visualizer is not here. But, when we, deploy this application, what we have is we've got this ingress point that's, pulling in data or data is being pushed to this point. For the demo, this ingress point is actually generating a bunch of fake data. And then it's kind of fanning out to two different operations. So we've got sorry, I'll zoom in here so we can look at this a little more closely. So we've got a Spark streamlet right here called car aggregation that's doing some windowing and aggregation on this data. So it's using all those timestamps as was mentioned earlier to to say, okay, in the last hour, what's the running average of these metrics that are coming in. And so that way we could write it into some other database, and later maybe someone could come back and look at the graph of their performance of the car during the day, something like that. And then over here, that same feed is being subscribed to by this car clustering application or streamlet. And so this one is really interesting because it actually forms an these two right here are just normal Akka streams applications, but this one is both an Akka stream and it's also forming an Akka cluster for those of you who know Akka very well. And so it's forming an Akka cluster and it's doing Akka cluster sharding to to do something specifically different with this car data that's coming in through here. And then so basically it's doing push notifications. So for a specific car, a car of ID 123, we want to be keeping an eye on, how many miles it's driven since its last oil change. And if you need a new oil change, we're going to, send you a push notification that, hey, it's time to get a new oil change. But that's a use case that's specifically really hard for something like Spark to do, because it can only look at data within that window. It doesn't have the concept of permanent data in memory. Once that something's outside of its timestamp, it's gone and it's erased. So Akka cluster sharding kind of is in it's another streaming tool. It's another thing that we can use to supplement our streaming application. So looking into what this actually looks like in code. So building a Cloudflow application, and I'll zoom in on these things as I get into them so that we can all see what I'm looking at. But building a Cloudflow application is it's a kind of schema first development practice. So the first thing that you kind of have to do is define the schemas for the messages that are going to be moving between your streamlets. And so I am using Avro. Protobuf is also going to be released really soon. So it's already been, the pull request has been merged, but currently Avro is supported also. So this is so the data that's coming in, this connected car e-record, I define it in my Avro schema here. Then I'll define some other metrics, and then just doing an SBT compile or something like that will generate the Scala case classes so that I could actually use this connected car e-record as a Scala object throughout the rest of my application. So once you define your schemas and kind of how messages are going to be moving around, then we can start defining streamlets. So as I mentioned before, the streamlet is that it's the box that contains our streaming logic with also the inlets and the outlets. And so really to write one of these streamlets, very simple. So all I have to do is first extend Akka streamlet, or if I want to have a Spark streamlet, extend Spark streamlet or Flink streamlet. So I extend that streamlet. I have to define the shape, what's the data look like coming in versus going out, and then define the logic for how do I, go from, inlet type to outlet type, or what's the stream that, feeds data to any of these points kind of look like. And so, first on the inlets, so I define a Avro inlet of type car e-record, and then I give it a little name. And then for my outlet, I have car alerts going out of this streamlet. And then if I wanted to, I can also define the sharding or the partitioning strategy as it goes into Kafka. But you don't have to do that. It'll do it randomly otherwise. So for now, I want it to be partitioned by car ID. And then when I define this, so for those of you who are familiar with Akka streams, this logic is just a runnable graph stream. It's just a normal Akka streams type. There's no special Cloudflow related. There's two little pieces that might be specifically, Cloudflow. So first, Cloudflow will provide you with this source with committable context. And so the source with committable context will take one of my inlets, and it'll provide me a source, basically a feed that's got Kafka offset data associated with it that I can, use here. So really all I'm doing is I'm writing for this case, I'm writing, I'm consuming data from the inlet source. I'm doing a map async to the car region. So I'm sending a message to the specific car that's associated with the message ID. And then I'm actually not doing anything else. Well, I'm committing the offset back. So after I get the response, the ACK that, the car actor has received my message, then I'm just, writing back into Kafka that the offset that says, hey, I'm done with this offset committed back to Kafka. And then, on the egress, I actually have this this source, which is a really cool tool in Akka streams. But basically, it gives me the ability from an actor to send messages to a source and still maintain back pressure. So really, what's happening here is I'm sending messages over to an actor, and then I've got kind of a break in my stream. And then when that actor decides it wants to send a push notification forward in this application, then it just does it sends a message to the source, and then those move forward to the egress point. So I know that was a bit confusing, and there's some specific Akka streams context here that people might not know. But did the core idea of this make sense, where you're extending this Akka Streamlet type, you are defining inlets and outlets, and then you're just building your logic? Does that make sense?
Yep.
Yep. Okay, cool. And then the last piece of this is defining our blueprint. And so now that I've defined this, I've got a couple different streamlets I've built out. I've got this the clustering one, I've got the data generator, I've got a printer, and then I've also got a Spark one. We'll look more at the Spark code in a minute. But I've got all these different streamlets defined, and now I want to define, I want to connect them all together. So to do that, we write our blueprint, and the blueprint is just where did I put it? Here it is. Just a configuration file where I define streamlets. So I define a streamlet called car data. I point it to a specific Scala class, and then I say the outlet.out of car data points at the inlet of car cluster and the inlet of car ag. So for those, when I named those streamlets earlier, that's what this out. I name all mine as just out and in. But I probably should do more verbose names like e-car messages in or something like that. But I define these connections, and on compile time, Cloudflow will actually type check this and make sure that I have strong typing across this Kafka boundary. So if I do sorry, let me make this. Can people see this? Is this big enough?
Yeah.
Yes, that's all right.
Okay. So if I do SBT verified blueprint, it'll actually check to make sure that given this blueprint that I've defined, that all of the inlets that I've defined in my streamlets and the outlets I've defined in other streamlets match up as described in the blueprint. So we can actually have strong typing on compile time, as opposed to deploying each of these individual streaming applications into Kubernetes and then checking on runtime if the schemas match up. And because we've got the schema management inside of the project itself, our Evero schemas are actually versioned along with these streamlets in Git. So now that I've verified my blueprint, and now we've looked at some of the code, and we can come back at the end and dive more deeply into some of these things. But before the end, I kind of want to make sure that we also talk about this piece. So the Kubernetes operator. So some of you may be more or less familiar with, I think everybody's heard of Kubernetes, but some of you may have not had personal experience with it so far. It's huge. It's coming down the line, I think, for everybody. And Kubernetes, this operator pattern, the idea of deploying a pod into Kubernetes that actually has Kubernetes related responsibilities is becoming more and more popular right now. And so that's what Cloudflow has, is this Kubernetes operator that is responsible for taking Kubernetes related actions for Cloudflow applications. And so taking what I showed you a minute ago from that, that IntelliJ project, building the Docker containers and deploying it into Kubernetes is just 2 commands. So I don't have to write any Docker, any Docker files. I don't have to write any Kubernetes YAML. I don't have to do any of that. Cloudflow, just based on this abstraction we've defined, is able to assume a significant amount about the plumbing of this application. And so SBT build and publish, it'll build Docker images for all of the Streamlets that we define, and then kubectl Cloudflow deploy. So this is just a Cloudflow. It's a kubectl Cloudflow plugin that interacts, as kubectl would expect with the Kubernetes API. And I just give it the Docker image that gets created here, and it's able to unpack that and deploy this whole streaming application. So yeah, let's actually see that work firsthand. So I am gonna type in this build and publish. I think it should be pretty fast. So SBT build and published right in my Cloudflow application directory. And once again, it's going to do all that type checking, or it's going to compile my Scala. It's going to do the type checking for the Streamlets on the blueprint, and then it's going to build my Docker container and then push those Docker containers to the designated Docker repo. And then it'll actually give me basically the kubectl command that I need in order to deploy the application. So here, it's already building the Docker image here, and then pushing it to Cloudflow. And a lot of these layers already exist because I pushed this application earlier, because sometimes the first time will take a significant amount of time. And so, if I had made changes, which I actually haven't, those would get updated on deploy. But I have to actually put one other little piece of data on here, which is some of the authentication credentials that I need for my for the Docker repo, just so that the Kubernetes operator is able to actually pull that image from this separate Docker repo. But there's ways that around having to put your username and password on every time. So now that I run this, it's actually going to just send a message to the Kubernetes operator that says, hey, we've got a new deployed application command that's come through for this Docker image. Go take care of that. And so the Cloudflow Kubernetes operator will actually go in and if this app wasn't already deployed, it would have created all the namespace and done everything necessary to deploy this app, including creating the Kafka topics, so that I wouldn't have to. Questions?
Yes, please.
Yeah.
The Cloudflow operator, how does it know about the sink and the source needed by the Streamlet, such as, for example, some JDBC database for the sink and some Kafka topics for the source? Where are those configured in the...
So anything that is Cloudflow operator itself is only taking care of things that are specifically in this space right here. So anything that I've kind of said externally managed, anything that is externally managed, like a like you said, like that Cloudflow it's like an external JDBC, or SQS or Amazon. It's not aware of those things. It can't do absolutely anything. So it's got its scope of command, which is making sure that these Kafka topics here are created in this Kafka topic, and that these things get started up correctly. And so that's really and then they're all deployed to Kubernetes. The namespace is created with all the correct security, like role-based access control rules. So yeah, that is where the extent of Cloudflow's responsibilities at the moment end. We've kind of thought about how to define the idea of this external connection, but we don't have a good idea of how to do that yet. But I think there's a huge amount of value in first just being able to do this. Any more questions so far? Cool. So let's see. And then, the last piece that I wanted to kind of point out was, scaling. Same thing, we could you could go into Kubernetes and edit the YAML and change the scale of any of these streamlets too. But at the same time, you could also just do it using the kubectl Cloudflow scale command. So for this, kubectl, the Cloudflow plugin, the command scale, the name of the app, which is connected car Akka cluster, the name of the streamlet or streamlets that I want to scale, and the number of the number of duplicates that I would like to see. And so now I can run that, and we'll be scaled up to 3 replicas. Sorry, I'll zoom in here so that we can kind of see that. So the Spark by default, the Spark applications here, they'll get. So this is a micro Spark cluster. So we're actually the Cloudflow operator is communicating with the a Spark operator that's deploying a Spark cluster specifically for hosting the for running this application in the Kubernetes namespace. So this is a 1 master and 2 executor Spark cluster, and then these 2 just have 1 pod behind them, and then this one here, as you saw a minute ago, I scaled to 3, and so it's now got 3 peers. And this one here is actually forming a cluster. So there's a relationship between these 3 peers, which wouldn't exist on these 2. But that's in the code. More questions? So this really, I'm happy to go. Well, I guess I have one little more little piece, and then there's some other topics that we could kind of dive into if people are interested. But really, as I was kind of working on this presentation, I really wanted to have a side-by-side comparison of situations where you'd want to use Spark versus Akka. And this was kind of brought up earlier. I mean, Spark, Spark is battle tested. People like Spark. It's got a really great community, and it's a really solid tool. It's exceptional for windowing and aggregation, those specific types of things, like making sure that as timestamps come in, we can wait for late data. We can group things based on timestamps. So if I'm waiting for 2 messages of a specific type that could come in, or 2 messages that can come in at different times, and I want to correlate them within an hour window or something like that, Spark is amazing for this. That's what it's for. It also has really great libraries for machine learning that could be potentially used to operationalize machine learning in streaming applications. Whereas the other side of it is Spark is an absolute beast for CPU and memory. It requires huge amounts of those in order to keep operating. Akka, on the other hand, is extremely low latency streams. It's really not about this streaming. It's not a streaming engine. It's a streaming, I guess, framework. It's not this it's just one node that's moving data from a start to finish through all these operations, and so it can be really low latency. It's got low initial CPU and memory footprint, and it's back pressured. We can scale this up really nicely, so I can just continually add more Akka streamlets, whether I'm clustering or not. That's not something you can do with Spark. So I can actually scale my Cloudflow application in my Spark streamlet. I can scale that piece, but how Cloudflow actually does that is it actually takes down the entire Spark application and spins up a new one with a new number of executors. Akka is able to dynamically add and remove nodes just because it's doing something different. And then, as for those of you who know Akka, Akka cluster sharding, Akka distributed data, these are really great tools that can be used alongside streams to do things that Spark simply is incapable of doing. And then all the Alpaca connectors. So using these 2 things together, I could, by the way, I love Spark. I'm certified in Spark. I use it a lot. So I'm not trying to just hammer on. I think people know Akka a little less, so I added some more things over here. But using these things together, building a relationship between these 2 engines, and using them where they're most appropriate, it starts becoming a really interesting way of building streaming applications. Whereas right now, like I said earlier, everyone is bound by Spark is for streaming and that's all we use, regardless of kind of what people are what it's actually needed for. So In summation, Cloudflow, it's really just these two pieces. There's this API to help you define these streamlets and to stitch them together. And then there's this operator that helps you get into a Kubernetes environment faster. One other piece that's kind of in the middle ground here is if I wanted to, I could actually do SBT run local. And this will actually spin up this. So Cloudflow has test kits for testing any of these streamlets for making sure that to build define test. But if you wanted to do some sort of integration test, run all the streamlets together and make sure data is moving through Kafka, you can do that all locally too. So what's happened here is it's actually within one JVM, it's spun up all of my streamlets, and it's actually using embedded Kafka to communicate between them. So you don't have to do a full Kubernetes deploy in order to see this thing run. You can just experiment locally. So it creates a really, really fast. So this is all this data moving through my local stream. So it creates an extremely accelerated development cycle on these complex streaming applications. So I build out a lot of demos and examples and things like that. And I create a completely custom demo basically every time I'm talking to different groups now, because it's just so easy to prototype these things and tune them and make changes. So yeah, Cloudflow is, when it comes to using all these tools together, it's significantly accelerated my speed at kind of taking advantage of these tools. If you thought this is a cool project, please go to the Cloudflow repo, pull it down, play around with the examples, file issues, pull requests. We'd love help, we'd love support, we'd love complaints. If there's things that you want, please let us know what those are, and throw us some stars. It's a great way for us to know if this is actually useful to people, or if there's something that we really need to change. So thank you so much, everyone, for your time. I really appreciate it. I'm not going anywhere. If people have questions, I'm happy to dive into any of these topics or dive into some of this other stuff that I hid. But that was really the core of what I had to talk about with Cloudflow. So thank you so much.
Great. Nolan, quick question. I know that we went through some of the code examples, but just curious, how easy is it to unit test a Streamlet, or are there, other unit testing libraries that are available to work with that?
Yeah, so there's the actual Cloudflow documentation is under cloudflow.io, and Cloudflow comes with a test kit for Spark Streamlets or Akka Streamlets or Flink Streamlets. So there is a built out unit testing framework within Cloudflow for these pieces.
Understood. And so since we end up using the Lightbend ecosystem a lot as an organization, one of the challenges that we had with fast data earlier was the fact that whenever there were version changes or new releases of some of these components like Flink and Spark coming up, there was a lot of configuration management and version control that we had to do, and fast data somehow never kept up with that. So do you think Cloudflow is better equipped for those kind of challenges, or do you foresee similar challenges here as well?
So something that actually is just got merged in the last couple of weeks. So if you were to take Cloudflow version 1.3.3, I would say yes, it absolutely has that problem. But the newest, 1.3.4 or whatever we're going to call it, 1.4, this newest version, takes a very different view on how to manage these streamlets. So currently, this project is really just building one jar, and that in one Docker image that has each of these, the code for all the streamlets in it, and that causes a problem. Especially, for example, I want my Akka streamlet to be 2.6.4 because there's really great things in 2.6.4, but Flink uses Akka, and Flink is far behind the most recent Akka version. Well, in order to combat this, there's a new we've set up kind of the idea of a multi-image build. So Cloudflow will now be able to build multiple jars and multiple Docker containers for each of these pieces, and and Cloudflow basically still does the same thing. I'm sorry, the Cloudflow operator still does the same thing, but now it can point, it can use a different Docker image for each kind of stage.
Mhm.
And so this creates a lot lower coupling between these, between any of these. So at least from the code's perspective, they're all completely decoupled. Now there's the other side of it though, where there will always be a little bit of lag. We as Lightbend will be fastest about getting the most recent version of Akka into things. There might be some lag when it comes to Flink and Spark, because we need to make sure that so deploying Flink and Spark is really about the Cloudflow or the operators designed to deploy those in Kubernetes. And so we rely on a Flink operator and a Spark operator to do that. And there may be some lag time between when those operators are updated to be able to deploy the newest version of that app. But with this framework, with the fact that Cloudflow is really just spinning up a Docker container that is being provided, once we can get it into the API, it should be very fast. And the idea that we can stop this one Streamlet and restart it with a completely new version of the code and just continue reading out of the Kafka topic. I think it's a lot of those challenges associated with, this same problem, the reason why upgrading versions of Spark is hard is because you need to deploy a whole giant, massive Spark cluster on the newest version of Spark, or I'm sorry, on the newest version, or, in Mesos or something like that. But with this, it's not along those lines. All we have to do is we have to have a Cloudflow, the Spark operator that knows how to spin up multiple versions of Spark. And, we could potentially have a Kubernetes cluster that has lots of versions of Spark, different versions of Spark doing different applications, across the cluster. So I think, how Cloudflow is abstracting this stuff onto Kubernetes will make that upgrade path for a lot of these things a lot easier. And it won't be like everything has to upgrade to the newest version of Spark. It can be a versioned thing.
Sure, thanks.
My question about infrastructure
Mm-hmm.
is every components need to be in Kubernetes. For example, let's say my company somehow use manage Kafka and manage Cassandra. They don't sit in my own Kubernetes because I depend on that provider to manage Kafka for me. Could that fit in the scenario? Could Cloudflow fit with that scenario?
Yes. So there's two pieces. Excuse me. There's two parts of Cloudflow that I always want to make sure that is clear to people. There's the internal Kafka, the idea of these lines on our diagram, and so there's that Kafka, and then there's potentially this Kafka. Both of them you'll very soon be able to use any Kafka anywhere. It's not a problem. And so if you wanted to even use multiple different Kafka clusters for different parts of your Cloudflow application, you could. And so in the 1.4 release that hopefully will be coming out in the next month, you'll be able to say, let me just jump into the blueprint. So this right here, this cardata.out, this is this becomes a specific Kafka topic. And so in the next version of Cloudflow, you will actually be able to tell it, I don't want you to create an internal strimzy Kafka topic for this. I want you all the Streamlets to use an existing Kafka topic that's set up in some managed Kafka service, be it Confluent or Amazon managed Kafka. So as long as it's got a compatible Kafka client API, you can use whatever Kafka you want. I will mention for all the other pieces though, those all have to be running in Kubernetes, because it kind of defeats the purpose of if the Cloudflow Kubernetes operator can't manage these things in Kubernetes, then we're back in this where there's no eagle eye view of this application. It's all just kind of a mishmash of pieces that are across all these different platforms and infrastructure.
Okay, so then manage Kafka, okay, but it's hard to be like compatible with Kubernetes. Is it what you mean?
Yeah, so manage Kafka for the communication protocol or just reading data in is super easy. But if you wanted, for example, to for Cloudflow to deploy a Spark application to an existing Spark cluster that's running on Mesos, we're not going to be able. We can't do that because the Cloudflow operator has no relationship with that. We don't have that API built, and I think that kind of takes away from the real value of Cloudflow too, because really we're trying to get away from that concept of an ad hoc architecture where each piece of this streaming application, we want it to be managed by the Cloudflow operator. That's what gives it the value of upgrading and deploying and monitoring. That's what makes it easy.
Okay, cool. Thanks.
Any more questions? And if anybody, if you, like I said, if you don't feel like speaking out loud, you want to just type in the comments. I'm happy to just read those. Or if people want to just, email me or anything like that, I'll put my contact info up here. If you want to send an email too, just ask me questions. I'm always happy to kind of dork out and dive into this. There's a lot of this example that I actually was up last night just messing around with. There's some really interesting things about actor and stream interop stuff that it does. There's some interesting things about, writing from actors back into streams. And then the next generation of Cloudflow will actually have some really cool external sharding strategy stuff. Basically making sure that if there's an actor that, if we're moving messages through, so these are Kafka topics. So if we're moving messages through a specific Kafka topic and we have a specific Akka node reading those messages, we can make sure that the actor that, that the actor that's paired up to message 3, U3, we can make sure that it's local and that you'll never need network hops. But that's a whole kind of very cool next generation side of, kind of stateful streaming in Akka.
Got it. And Nolan, from an industry adoption perspective, do we have this in production yet, or most of the clients they are evaluating it?
So most customers are definitely still in an evaluation phase. It is in production though, at a customer or two. I'd have to go check the numbers.
Okay.
But yeah, but yeah, still a very new framework. Like we said, I think it was just 3 months ago that we open sourced.
Understood.
Yep. Any more questions? Cool. Well, thanks again, everyone. Thank you for having me at the Toronto Scala user group. Happy to talk about Cloudflow. As you guys probably are aware, I'm always happy to hear myself talk. But I appreciate you guys giving me the opportunity to talk about Cloudflow and kind of introduce you all to it. And if you do have feedback, please, we're dying for feedback. I'd love to hear people's experience, even if it's just playing around locally, kind of what you think about building applications in this way, because it really does change the dynamic around building a streaming application.
Thanks a lot, Nolan. That was a great presentation.
Mm-hmm.
And if anyone has any further questions, feel free to reach out to Nolan. You can reach out to me too. I've worked on this team for a little bit. Don't currently work on it, but it's still very much the same from when I did. Thanks for everyone joining. We're gonna try and keep the ball rolling and have more frequent events. These virtual events are fairly easy to pull off, technical issues aside. So
Exactly.
we'll probably have some more talks lined up, and we might try some other formats too, like an unmeetup type format or a tutorial of some kind. So yeah, thanks everyone for joining.